Good morning, students. Myself, S.V. Jirli, working as senior lecturer in the Keli Society's Srimati C.I. Munolli Polytechnic, Hubli. Welcome you to the online class in the subject of Engineering Mathematics Part 1. Dear students, please note that the study material that we are sharing in this online class is prepared by a teacher referring to the textbook Engineering Mathematics Part 1 written by S.V. Jirli, Senior Lecturer, Keli Society's Srimati C.I. Munolli Polytechnic, Hubli. Some of the points to remember for taking online classes. Dear students, treat every online class like a real class, and you are informed to attend the online classes regularly. Keep the 100 or 200 page fair notebook ready, and while going through the presentation, we suggest you write down all the contents and examples in the notebook so that you can refer and revise easily. Note that there are number of examples which are solved, and we advise you to solve the examples from the exercise which are very much similar to the solved examples. Dear students, your active participation is very important. We wish you all the best. Let us know the chapters in the subject of Engineering Mathematics Part 1, subject code 15SC01M. In algebra, the first chapter, we have matrices, determinants, inverse of matrix and applications of matrices. Second chapter is vectors. Third chapter contains probability and logarithm. Next we have trigonometry section. Fourth chapter, here we study ASTC rule, trigonometric functions of standard angles and allied angles. Then we have compound angles, transformation formulae, trigonometric functions of multiple and submultiple angles. Fifth chapter is complex numbers. Finally, we have introduction to calculus. Sixth chapter, limits. So these are the sixth chapter in the subject of Engineering Mathematics Part 1 in first semester. Let us know the detailed course content of first chapter, matrices and determinants. Matrices. Here we start with basic concepts of matrices, definition, types of matrices, and we have examples on addition, subtraction and multiplication of matrices. Then we have determinant, definition, an example on determinant of second and third order, finding unknown quantity in a second and third order determinants. Then we have solving simultaneous equations. using determinant method, or it is also called Cramer's rule. Next, we have inverse and applications of matrices. We begin with the definition of minors and cofactors. With the help of this one, we find adjoint and inverse of matrix. Next, we have characteristic equation and characteristic roots. They are also called eigenvalues of second order matrix. Then we have statement of Cayley-Hamilton theorem and its verification for 2 cross 2 matrix. Next, solution of system of linear equations using Gauss elimination method of 3 unknowns only. So this is the detailed course content of first chapter. This first chapter contains 31 marks in the annual question paper. Here we start the first chapter, matrices. Dear students, during the online class, watch the presentation of the video carefully. We suggest you watch and listen to each sentence and examples so that you understand clearly. You can pause and play and write the same content and examples in the notebook, and you try to answer yourself as much as possible because all the steps are explained in detail. Please note that regular practice is very much necessary to get the better results. I repeat, watching the presentation of the video, listening and writing, all these are to be done simultaneously. Thank you. Here we start the first chapter, matrices. What is matrix? Definition, please write down. A matrix, in plural it is called matrices. A matrix is defined as an ordered rectangular array of numbers or elements. These are arranged in rows and columns and enclosed within a bracket, square bracket. We usually denote the matrices by capital letters A, B or C, etc. Example, here we see the matrix A, 8, 4, minus 5, first row, 9 minus 9, 1 is second row, is a matrix of order 2 cross 3. This means that the matrix A has 2 rows and 3 columns. So we say the size or order of matrix A is 2 cross 3. It is pronounced as 2 cross 3 or 2 by 3. One more example, let us see. Matrix B equal to, this matrix contains 3 rows, 3 columns. So it is a matrix of order 3 cross 3. One more example, matrix C equal to, here we see 1 row, 4 columns. We say it is a matrix of order 1 cross 4. I assume you are copying all these things. You can pause and play whenever you want. Let us move to the next. Few types of matrices. There are several types of matrices, but most commonly used are the following. The first one, row matrix. It is a matrix having only one row and any number of columns. For example, we see matrix A equal to 7, 4, minus 5, 8. This matrix contains only one row, 4 columns. We say it is a row matrix of order 1 cross 4. 1 indicates row, 4 indicates number of columns. Similarly, matrix B equal to ABC is a row matrix of order 1 cross 3. Next, column matrix. It is a matrix having only one column. For example, matrix A equal to, here we see only one column, 5 minus 1, 2, 0, and 4 rows are there. We say it is a column matrix of order 4 cross 1. Next we have zero matrix. It is a matrix in which all the numbers are equal to 0. For example, here we see the matrix contains all the numbers are equal to 0. It is a zero matrix of order 2 cross 3. 2 rows, 3 columns. Let's move to the next. Square matrix. It is a matrix in which the number of rows are equal to the number of columns. For example, we see 3 rows, 3 columns. Therefore, it is called square matrix of order 3, or also it is called 3 cross 3. In this square matrix, please observe the diagonal from left top corner to the right bottom corner is called principal diagonal. I'll show you. You also mark it. Here it is marked. This is principal diagonal. Next type of matrix, diagonal matrix. Please write down. It is a square matrix in which the number of all the elements except the elements in the principal diagonal are zeros. For example, the matrix A equal to, here you observe 7, 9, minus 2 is principal diagonal and other elements are equal to 0. We call it as a diagonal matrix of order 3 cross 3. Next we have scalar matrix. It is a diagonal matrix in which all the elements in the principal diagonal are identical, means same numbers. For example, here we see 7, 7, 7 is principal diagonal containing same number. Therefore, it is a scalar matrix of order 3 cross 3. Hope You are copying all the things clearly. We move to the next now. Identity matrix or unit matrix. It is a diagonal matrix in which all the elements in the principal diagonal are equal to 1. It is denoted by I. For example, you see I equal to, note the principal diagonal 1 1 1. This is identity matrix. One more example, I equal to 1 0 0 1. These two are identity matrices of order 3 cross 3 and 2 cross 2 respectively. Transpose of a matrix. Let us see what is transpose. Suppose A is any matrix, then the matrix obtained by interchanging rows and columns of A is a new matrix called the transpose of A. The transpose of A is denoted by A raised to T or A dash. Example will make you understand better. Let A equal to the matrix, you see, first row 7 9 minus 4. Write down second row 5 minus 8 11. Then what is A transpose? A raised to T. Here we interchange row and column. 7 9 minus 4 is first row. We make it as first column. Next 5 minus 8 11 is second row. Here we write it as second column. This is A transpose, A raised to T. Let us try one more example. Let A equal to 2 minus 1 minus 3, 5 8 4, 3 9 11. Try to answer what is A raised to T. What is first column? First column would be 2 minus 1 3. Second column is 5 8 4 and third column 3 9 11. This is A transpose, very simple. We have few notes based on the transpose of matrix. Suppose A is a matrix of order m cross n. M cross n means m indicates rows, n indicates columns. Then what is A transpose order? A raised to T is a matrix of order n cross m. Second note, the transpose of A transpose is A itself. Hope you copied. Let us move to the next. Here we study addition and subtraction of matrices. We can add or subtract matrices only when the orders are same. Let us see. Here we see A and B are two matrices of the same order, 2 rows, 3 columns. Then how to get A plus B? or A minus B. A plus B or A minus B is also a matrix obtained by adding or subtracting the corresponding elements of A and B. Let us write in detail what is A plus B or A minus B. A plus or minus B equal to, write down matrix A plus or minus matrix B. So here we are adding or subtracting the corresponding elements. The next step gives clear idea of addition and subtraction. A plus or minus B equal to A plus or minus L, first row of first matrix plus or minus first row of second matrix are to be added. First element, then here first element, A plus or minus L. Similarly, what next? B plus or minus M. Next, C plus or minus N. This is first row. Similarly, what is second row? Try to answer. P plus or minus F. Next, Q plus or minus G. Then R plus or minus H. This is the way how we add or subtract two matrices. Let us do examples on addition and subtraction of matrices. Write down the example. If A equal to 7, 4 minus 11, 9 minus 8, 2, and matrix B equal to 2, 3, 4, minus 1 minus 5, 13, then find A plus B and A minus B. Solution means answer. A plus B. Please write down A plus B equal to matrix A plus matrix B. Given matrix A and B equal to matrix notation. How to add two matrices? First number 7 plus 2. Similarly, what is the next number? 4 plus 3. Next, minus 11 plus 4. Try to answer the second row. 9 here, plus of minus 1 is minus 1. So plus into minus is minus 1. We are writing 9 minus 1. Similarly, next number would be minus 8 minus 5 plus into minus minus 5. Minus 8 minus 5. Next is 2 plus 13. Therefore, what is A plus B? Simple addition of numbers. 9, 7, minus 11 plus 4 is minus 7. Second row, 8 minus 13, 15. This is A plus B. Next paragraph. Let us find A minus B. Here matrix A minus matrix B are written equal to, write down. So how to subtract now? First number minus first number of second matrix. that is 7 minus 2. Similarly, next 4 minus 3 minus 11 minus 4. Second row is 9 minus of minus 1 becomes plus 1, minus into minus plus, 9 plus 1. Please observe the next number. Minus 8 minus of minus 5 is plus 5, minus 8 plus 5. The next number 2 minus 13. Therefore, a minus b equal to. Subtraction of two numbers. Try to answer yourself and compare the answer. 7 minus 2 is 5. 4 minus 3 1. Minus 11 minus 4 is minus 15. Second row is 10 minus 3 minus 11. This is the answer, a plus b and a minus b. Hope you understood. Let us try one more example. Please copy the example. If A equal to matrix written and B equal to the matrix, then the question is find A plus B raised to T. It means transpose of A plus B. Here we have to plan the steps. First we find A plus B, then we take the transpose of A plus B. Let us see in detail. Solution: A plus B equal to, write down the matrix A plus the given matrix B as it is, equal to, add the numbers. First number 5 plus 2, next 8 plus of minus 1 is 8 minus 1, next we have 7 plus 6. This is the first row. Try to answer second row. 3 plus 1 minus 9 minus 4, then minus 4 plus 11. What is third row? Please try to answer yourself, then you check. 1 minus 1, minus 1 plus 1, and 10 plus 3. Therefore, A plus B equal to the matrix. Simple addition of numbers we see. Add the numbers. So, what is first row? It is 7, 7, 13. Second row 4 minus 13 plus 7. What is third row? It is 0, 0, 13. This is A plus B. The question is A plus B raised to T. We have to take transpose of A plus B now. Therefore, A plus B raised to T equal to. Transpose means interchange of rows and columns. Here we see 7, 7, 13 is first row. We make it as first column. Next, 4 minus 13, 7 is second row. We make it as second column. Then 0, 0, 13 is third row. Here we write it as third column. This is A plus B raised to T. Hope you copied all the things. Let us move to the next. If A equal to the matrix 8 7 minus 15 3 9 minus 4 and matrix B equal to 2 4 7 minus 5 2 minus 3, then find A minus B raised to T, transpose of A minus B. It's again similar to previous example. It was addition, this is subtraction. Let us see the answer. A minus B equal to, write it clearly, the matrix A minus the matrix B equal to subtraction 8 minus 2. Next we have 7 minus 4, second row, minus 15 minus 7, and 3 minus of minus 5 becomes plus 5. Please note that it is 3 plus 5. Similarly, third row, try to write yourself. So please check the third row. 9 minus 2 and minus 4 minus of minus 3 becomes plus 3, minus 4 plus 3. Next step, what is A minus B equal to? The matrix. Subtract the numbers. First row 6 3. What is second row? Minus 15 minus 7 minus 22 and 3 plus 5 is 8. Third row, it is 7 minus 4 plus 3 is minus 1. This is A minus B. And you see the question, A minus B raised to T. That means transpose of A minus B. Here we take A minus B raised to T. The transpose of A minus B we write. 6 3 is first row. Make it as first column. Minus 22 8, second row. Here second column. 7 minus 1 is third row. Write it here, third column, 7 minus 1. This is transpose of A minus B. Hope you copied. Let us try one more example. If A equal to the matrix 7 8 minus 15 19, then find A plus A transpose. This is very simple. You see the answer. A plus A transpose equal to, observe that matrix A 7 8 minus 15 19 as it is you copy, plus the matrix is A transpose. It is not yet written. Try to answer what is A transpose. 7 8 is first row. Here it is first column 7 8 because we are taking transpose of A. Minus 15 19 is second row. Here we write second column minus 15 19. Next, addition of matrices. 7 plus 7, 8 minus 15. Second row is minus 15 plus 8, 19 plus 19. Therefore, A plus A transpose equal to, this is 14 minus 7 and 38. This is A plus A transpose. Hope this is clear. The examples on addition and subtraction. Thank you. We meet in the next class.